Alright, so let's start talking about it. It looks like we got some rough drafts in there. So the height of the females when they was at 5 years. When they were 5 years old?
Yeah.
So, hey guys, let me ask you a question. What am I asking you to interpret or explain what it represents in context?
The y-intercept.
The y-intercept. All of your answer, or none of your answers address the y-intercept. Well, y'all are addressing the y, not the y-axis, the y what?
Value.
Or variable, right? But what is your y-intercept?
50.3.
It's what?
50.3.
Is it?
Oh no. I would say 50.3.
Yeah, it is 50.3.
Sure about that?
It's just backwards.
Okay. I mean, I would agree that the 50.3 is a part of my y-intercept.
Oh no, 50.3 plus 6. No.
Y'all are forgetting one of the most fundamental parts of the y-intercept, and we're going to have an understanding check on this, and you better write this down to remind yourself of this. What do you know about every y-intercept that has ever existed? So what is the y-intercept?
No, 6.
5.
Is it?
What did you just say is true for every y-intercept that has ever existed? X is equal to 0.
Oh, 0, 50.3.
Oh, it's
I was
like
about to say that, but then I don't know why my mind just said, "Don't say it, bro. Don't say it."
say it, bro. Okay, we're good with that, right? Like that's what a y-intercept is. If you don't write this for the y-intercept, you will be limiting your ability to show me mastery of these concepts on an understanding check, because we need to recognize it's 0 what?
0, 50.3.
No, but 0 what? Like what's?
At 0 years, the height is 50.
Okay, so I want to pause for a second. I want to point out someone in their bell ringer said when the girls are 5 years old, right? Because we might be thinking, hey, that's the starting point. But it doesn't say that the model starts at 5. It's just saying that the model is only appropriate for girls aged 5 to 18. But it still be 0 what? 0 years old. And that's based upon the way we defined our variables up here. Final draft of what is the input variable? Age of females between the ages of 5 to 18, right? Now it is all about the females aged 5 to 18, but it's just the age of those females, not starting at 5. Jakeem, you get with that detail? Okay. So 0 years old. Remember, this is what I would do for my rough draft. I would write out my y-intercept and I would address these things. 50.3 what?
Oh, centimeters.
So 50.3 centimeters tall. Or you can say that the height is 50.3 centimeters. So let's look at a rough draft. Or not a rough draft, a final draft based on that rough draft and what you already said. We're going to come back to it. Yeah, we are on the bottom one. Everyone else did slope yesterday, and so everyone else is doing y-intercept today. We're starting with y-intercept, and then we're going to do slope. Okay. So what is a note that you should probably make to yourself on this bell ringer to help you study and prepare for an understanding check that's going to involve interpreting slope and y-intercept? You need to write that y-intercept as a what? That's not just true for interpreting, that's always true. Do not forget, with a y-intercept, we are always going to write it as a point. So what would our final draft be?
Well, you can't say the y-intercept.
You can, but I wouldn't.
Why?
Wasn't this the one I was just using?
0, 50.3, and then describe after, like, for the.
Okay, so I mean, we already have that, right? So you would write your y-intercept, but then final draft, so like, how would we interpret or explain what that said?
At 0 years old, the height of the female would be 50.3 centimeters.
At 0 years old.
The height.
Approximate.
Oh, that's right.
Yeah.
Because is that the actual data or is that a model? So at 0 years old, you could say that the height,
50.3 centimeter hat. Can you use it in a
well, so what you would say instead is, what is that hat really saying?
prediction?
It's closer to prediction. You can say approximately, but the height of females, is there anything else we should say about those females?
From 5 to 18 years
Yeah,
But it's talking about 0 years old.
so this is talking about 0 years old, so we may not want to include that detail here. The height of females is predicted to be, or is approximately, I would say predicted to be 50.3 centimeters. Notice we have both the x and the y. If you are ever interpreting in context, you need to address both the x and the y, okay? So now we are going to do slope.
So nobody in the yesterday take it?
Y'all are all taking the test. You're all male juniors.
I started from here first period today and learned. I said I couldn't.
I was only going to allow that if we could all do it. All right, next bell ringer. Doing the slope this time. So work on your rough draft. Think about some key ideas we just discussed for the y-intercept to help us do a rough draft of the slope. It looks like we have the context. Okay. Who's typing? Voter's typing. Continue with that statement. Okay. So I know one of us still hasn't gotten our answer in there yet, but I wanted us to look at the two responses so far. What detail, important detail, is missing from one of them?
Y equals 0.
Does y equal 0? The actual slope, right?
Oh.
The predicted rate of change, is it the predicted rate of change? Yes, but first off, in reference to what variable? But what's the y? Remember, this is why we define our variables first.
Y is 0. Oh, wait, no, whoa.
What is the y?
Y is 50.3.
You're cutting part of that off. The y, what is 50.3? The y intercept. We're not talking about a y-intercept right now. I'm asking what is the y, the output in general.
Age of the few.
Would it be 5?
What is the y variable in general?
The height of the beam.
It's the height, isn't it? Wasn't the height dependent upon how old they were? Okay? And so we want to recognize it is the predicted change in height. It has something to do with the predicted change in height for females 5 to 18. So not between, but for females 5 to 18. But what is that predicted change in height? 6.01 what? How often is that 6.01 happening? And so I want us to notice. Wait a second. Hold on. Jakeem. Is age being multiplied by 50.3? Look at that equation again. Look at that equation. Is that age being multiplied by 50.3?
Oh, no, age. No problem.
Yeah, remember, the slope is actually here. We just said that this was the y-intercept, or part of the y-intercept. This is my slope, because slope is what kind of rate of change? Constant additive, right? And what operation is going to show that repeated addition? Multiplication. So this multiplication is telling me what my slope is. But okay, I need y'all to remember, because we're missing some important details. For a y-intercept, we said we're going to write it as a what first? Point. How do we need to write the slope so that we can then interpret it?
6.01, comma 0.
8.
Is it comma 0?
No, it's 8.
What kind of point? What would this be? That'd be an x-intercept, and also that's not the x-intercept.
It's 6.018.
That's the slope?
No.
Remember, only that's the slope. The x is not my slope.
So it's 6.01.
6.01. But I need y'all to remember,
Equals.
is y hat equals? I thought I'm just trying to figure out the slope. Say that one more time.
Divide by 1. Because it took me, I was like, I know it's something, but.
Remember, the slope is 6.01 divided by 1. Why do I need it as divided by 1? You've got to remember that for your rough drafting, right? You need to write your slope as the change in y divided by change in x. Because remember, so pause for 1 second, I'll let you write that in a second. Over here, when you wrote your y-intercept as a point, you had both an x and a y. For slope, in the same way, you need a change in y and a change in x. And for part of my rough drafting of this, I would make the note, hey, this is the change in what? It's change in y, what's the context for that? The change in their
No.
Change.
height. Wasn't the y all about the height? divided by the change in their, now we can write a more effective, right? A more effective interpretation or explanation of what that represents. So if I were you, write the slope as change in y divided by change in x. That's going to give you the interpretation, or help you get that interpretation. That's where I would start. But I will point out, that means you're always going to have to rewrite it as something divided by what?
1.
Yeah. Because if you're looking at real world data, we're almost always going to have a decimal. And so it's going to be divided by 1, and you want to keep that in mind so that you have both a change in y and a change in x. Do y'all want to take a little bit more time to brainstorm this solo, or do you want to do the final draft as a whole class?
That's right.
What?
That's right.
Right, but have we written this out?
No, I mean, we did our rough draft, so we can do our final together.
We're good to do a final together? Okay. So how would I final draft this?
M equals 6.01.
Well, remember, that's part of your rough draft. Like, okay, so one thing I want to point out is, because someone, I think it was someone yesterday, and so I didn't see y'all yesterday, they had the question of, well, how do I show my evidence for my representation, right? Or what it represents. So remember, you're going to have a final draft here, right? This is my rough draft showing why I got the final draft. So this final draft would be my claim, the rough draft would be my evidence. Does that make sense? So this is what you're using to build into here. And so I wouldn't rewrite the m equals 6.01 divided by 1, because that's a part of my evidence. It's already there. For the final draft, how would I explain what this means?
It means it is the 6.01 is the, what did I say earlier? Oh, or
Go back to what Keyshawn's saying. What did he say?
As the age increases.
Why are you starting with the age if it's in the denominator?
because it depends, the height depends on the age.
Right. Start with which variable first?
Why? I mean, X.
The x, the independent. Start with the cause, then write about the effect.
So it's
Now-
like a point X and Y.
Kind of, except we need to be clear and be careful, is this just an x? Because we're not talking about when a female is 1 year old, we're saying that the age is changing by
One.
1. So what should we say there?
As
As
the
the
age
age
increases,
increases, the
we can plan.
So as, not just age, but as females age.
increases 1 year.
So I want to point this out. I just said change earlier. How did you know it was increasing?
Because it can't decrease. Well, it can decrease. No, it can't decrease. It ain't gonna decrease. I mean, that's just common sense. It can't.
Age can
There's something here that tells you it's increasing.
Oh, it's positive.
It's positive. So as a female's age increases by 1 year, thanks sir. Did you get down, oh, did you know that, okay, so you went to the office?
Yeah.
Okay. Whose name is that?
Let me wait, cause I'm a football teacher, she just run me.
So she wrote you has to go to the office, I got you now. I was like, Miss Wicks isn't down in the office, but I got you.
I'm going to say.
I told you, I was pretty sure that's where he had to be. Alright, so as female's age increases by 1 year, then what?
The predicted
The predicted what?
rate of change, or no, you ain't gotta say rate of change, the predicted change in height.
The predicted, is it just change?
Increase.
Why does it increase?
The predicted increase.
It's positive
It's positive again, right? The predicted increase
in height
in height
is 6.01 centimeters.
There we go.
You know, they there.
Yeah, we're on that one right there. So it's important, and so you'll notice over there we already have the y-intercept done, we just finished the slope. So again, I need you to remember the rough draft is important. If you don't write out the slope as that change in y divided by change in x, it's real hard to then get the final draft. if you don't write out the y-intercept, and that should say y-hat, as a point, it's really hard to then interpret it because we don't have both the x and the y. You want to make sure you get both of those written out effectively before you interpret it. Alright, so one last quick poll question. It's a fairly easy one. You can ask it out loud if you want, but go ahead and answer this poll question. I'll leave this up here. So if you want to just ask a question out loud, you can do that. This just so that you have anonymity in asking the question if you want to. You also don't have to ask a question. Just want that option out there.
This may be more about the taste.
Huh?
Maybe more about the taste.
The understanding check we have tomorrow, or the test overall.
I just want to know, like, do we get points named out if we phrase it the wrong way? Like, if we do cause and effect, but we phrase it like differently from what you.
Okay, you got to change your mindset. It's not about taking away points or giving you points. The rubric is all about showing you how well I see your understanding, right? So you can word it completely different than I word it as long as you have the complete context, right? Another way we could have said this is, and you could have even done effect then cause if you had said, hey, women between the ages of 5 and 18 typically increase in height by 6.01 centimeters every year that goes by. Notice that, but as long as you have all the context there, you can word it however you want. But you need to have clear evidence for why you're saying what you're saying, and then you need to word it in a way that gets that full context, right? So it's one of those things that, I need to do a better job of explaining this at the beginning of the semester. That rubric is not about giving you points or taking away points. It's all about the level of understanding that I see in your evidence and your claims, right? So I know that we're trained to think that, oh, teachers take away points. That's not how I work. Any other questions that we have here? No other questions typed out? Not really? Okay. So I'll stop that poll. Unless, Preston, you want to ask a question? Oh, okay.
Can you run a slow baptize over there?
One of these?
Yeah. Rounds for like bricks.
Alright, class. For some reason, Jakeem, I never got your document the other day, so I'm going to send this back out to you. Who doesn't take a break? Oh, from eating? Speak the truth,
You don't
man.
take a break from teaching.
Accurate. Hey, what's my job?
Teaching? The job almost over, you can leave chill out.
First off, my job is never almost over, and let me ask you a question. How pissed would Coach be if, with 2 minutes to go in the game, you just quit playing?
Very?
Very. You
What
finish the game.
But
You
look.
you finish the drill.
But
You
let me
play
tell you
all 4
Let me
quarters.
tell you something, if blowing everyone out, I just sit and chill, let them.
Hey, but someone else plays, don't they?
Yeah.
So, but here's the thing, I will say this. If y'all are blowing someone out, you're gonna chill. But if the people on the field aren't putting in their best effort, is Coach gonna be happy or is he gonna be pissed?
I mean, he was tough and kick back up.
I don't know what you just
No,
said.
fool. Remember what happened, Brian?
Oh,
Boy,
bad.
Like, if y'all quit hustling, he's gonna be pissed, even if there's 30 seconds left in that game. I would be. You finish the drill. Y'all about to have 2 months off. So we're gonna work hard in the next 2 weeks.
2 months.
Nah, we ain't gonna have 2 months off.
2 months off of learning. You got all of
gotta
your,
learn.
you got all out of the classroom. You chose to play football. That's extracurricular.
Dude,
Your
we only
job
got 2
is to be a
months of
student. June, July, and the first 2 weeks of August,
No
roughly.
way.
Yeah.
What do you mean, no
Right.
way?
That's
School in
too
Texas
short.
don't even start
No,
until
it's
like
not.
Too short.
August 22nd
Okay.
or late 26th.
Hey, at least we're not like some schools, but some schools go year round.
I would
Yeah.
personally actually prefer that because you know they have like 2-3 weeks off
Yeah.
periodically. I would love to have like, oh man, the first quarter's over, let's take a 2-week break.
Yeah. I like
Let's take a 3-week break. I would love that. But hey, Preston, you know what I'm about to say to you, sir?
Oh, my fault.
Thanks, sir. Do we all get our phones up? Preston, did you remember to put up your phone when you came in?
I'll flip it around.
Thanks, sir. So, I'm glad I remembered to plug this in before we get started.
if I make this little shot without looking, we can end class 5 minutes early.
10 minutes.
5.
I'll pray.
5 is more
Huh?
considerable.
I'll pray about it.
5.
Y'all know that you had 90 minutes without me yesterday.
Go to go outside there.
You suck.
Oh, too bad.
Paper.
Too bad.
Just stick
Too
to blocking.
bad. Okay,
Paper though.
it don't matter.
Stick to blocking, dude.
Okay, so we are working on that lesson 3 that we started the other day, where we are trying to linearize a set of data by applying an operation. You should have gotten that file back, and you should have that sheet of paper out. The understanding data in context was the old one. Keep that out because you may want it to help you with things, but it should say lesson 3, transforming nonlinear data. That's the second page. There's one more page to it. There you go.
I wonder how perfect old guys is. Remember?
Tomorrow.
Oh.
I will remind you all about that tomorrow, or at the end of class.
The whole front.
No, just the first 4 or 5 words. Can't remember.
I know it's over.
So, I can linearize a set of data by applying an operation, and so that whole linearizing process is to help us learn about what type of functions. Inverse functions. So that linearizing idea is going to help us learn about inverse functions, and this is just the foundation to do the next lesson, which is going to be really important for that. But I need you to pay attention to this. We're going to use that to then write an equation for the original data set by using the equation from the linearized data set. Now I do need y'all to remind me where we stopped in this
Stop
class.
right there. Number 2. Stop there. We
Task
wrote
2
our-
questions,
We wrote our equation.
right here.
No, I'm talking about objectives. We wrote our equation. We wrote our equation right before we left.
Okay, so we got down to here.
Yeah.
Okay, so we did not get to quite to that second objective yet. We started talking about this then. Man, look at how many markers I just have sitting through here. And I wonder why I lose them all. Okay, so somebody give me a linear model. First off, does everyone have a linear model? Yes. Okay, good. Somebody give me a linear model that they wrote.
0.33.
8.
X minus 0.3.
0.3 what?
35.
Okay. Is anything missing from this?
Oh, wow.
Say again.
FFX hat.
F of x hat, or you could say, what did Caleb say?
And Y hat.
It's supposed to be y equals?
It's square root. I thought we.
We're about to get to that. We're about to get to that. Hold on. Hold on. So this is what we should have in this area. Okay? You should have a linear model there. And what I would make a note of to yourself next to that model is this model is for the linearized data.
Wait, what were we writing it? I thought it was on now. Well, now it's.
Yeah, that would
Huh?
be
We're about to get to here.
No, not that one. The one right above it. We wrote it right there now. Under now. Like what the equation is.
Oh, did you write that equation down here?
And now. And now.
Oh, I remember why. Because I didn't realize. So I messed up on the slides and didn't have this part in there. Write that equation up here, or you can leave it where it is, or just draw an arrow up. I'll show you why in a second. Okay. One thing I will point out is this, because this will help you with interpreting and figuring out what these things represent in context. When we say y hat, what was the variable associated, the contextual variable associated with the y? Do you remember?
Was it
I don't remember. Let's look at 2.2. Actually, 2.1 should tell us. Come on. So problem 2 presents data that is nonlinear. It presents the total stopping distance in feet of a vehicle based upon the speed in which someone is driving. So what was y hat?
Speed.
It was the speed. Ooh, was it? Was it the predicted speed?
Yeah, cause the hell.
So the speed though was the output?
Oh, no.
When they apply brakes.
Yeah.
So it was when they applied brakes, but what about when they applied brakes? How long it took them to, so notice how it said it took them, how long it took them to stop based on the speed. So one thing that I'll point out, this is a lot like what the bell ringer was. If I were you, I would do something like this. Stop underscore distance, or DIST. I believe that's what's in the calculator, and it's the predicted stopping distance, right? So I could put a little hat above it.
And then you gotta put a square sign right next to it.
Well, we're gonna get to that in a second. This is what I would write up here. 0.33 times, what's my x? It's like someone getting murdered out there, but, come on, what was the x, the input, the independent variable? There's the stopping distance based upon their miles per hour, which is their, so you can put speed or miles per hour here. Notice that's the model. Now, if I'm trying to get that's the model for the linearized data. If I'm looking down here, y'all were all correct, and we're going to pick up here. Right now, what are we trying to develop? The model for stopping distance. So is that the linearized data or the original data?
Original.
So we want the model for the original data now. And that's what this was really all about. So the space underneath there, that's what I would write. And so y'all already talked about it. What really happened? It wasn't y hat. What happened to the y? What did we do?
Square root.
We had taken the square root of y hat is equal to 0.33x minus 0.35. And when I'm writing the final model, I'm going to use stopping distance and speed. It's just easier to use x and y while working. So what am I going to do at this point to figure out what y hat is equal to?
Solve.
Okay, what do you mean?
We got the square root on the side.
So we're going to square root this side as well?
Yeah.
Now I just took the square root of the right hand side, so that means I need to take the square root of the left hand side.
Do it
Because-
first.
Okay, because I'm going to come back to that in a second. The reason why I say that, Preston, is I know what you're thinking is, you're saying, okay, because we have a square root here, we need to take the square root over here as well. But remember, that square root